Hello students, welcome to my online physics class. Today the topic is to find out the relationship between the drift velocity and electric current. And the expression is I is equal to NEAVD, where VD it is actually standing for the drift velocity. Start. Take a small piece of cylindrical wire, this one, and the area of cross section, let us suppose it is A, and the length of this cross section of wire is actually it is L. So what will be the volume of the conductor? It will be area into length. Now let us assume one thing, that the free electron density, that is no number of electrons per unit volume, it is n. So the number of free electron in the conductor will be equal to NaL. N is the density, electrons per unit volume, and volume it is Al. So the total number of free electron in the conductor will be equal to NaL. Okay. Now what will be the charge of these number of this number of free electrons? So the charge, to find out the charge, we have to multiply the whole expression, this NaL, by E, where E is the electronic charge and it has a value minus 1.6 into 10 to the power minus 19 coulomb. So the total charge is NaLe. Now current is flowing through this section of this small piece of wire. So the charge leaving, okay, this section, okay, definitely they will leave. So what will be the time taken by the charge, all these charge, okay, to leave this section of wire? So there is one is a very basic formula: time is equal to distance by velocity. This one, time is equal to distance by velocity, L divided by Vd. So here L is the length of the wire, that small section of wire, and velocity is the drift velocity. And we have chosen here drift velocity because this is the average velocity with which the electrons are being drifted towards the positive end. Now again we know I is equal to Q by T. It is already known. Just put the value of Q. This one, this is the Q, and this one is the L. Okay, this one, and this one. Putting all these value, we will get NaLe divided by L by Vt. L will cancel out and we will get the expression here, I is equal to NeaVt, this one. And just putting the value of drift velocity, which we have already deduced. So if you haven't seen this expression, I will ask you to see the previous video. So the drift velocity, after putting the expression for the drift velocity, the expression for the current becomes I is equal to ANE square tau E divided by M. So this is our final expression. We have to prove it. Okay. Thank you for watching this video and I hope you will are enjoying it. Thank you.